Good day, in this video we will be discussing the prisoner's dilemma. The situation is this. Two suspected criminals are arrested. The police think that they were trying to rob a store, but the cops only have enough evidence to prove that they were trespassing. Thus, the police need one of the criminals to rat out the other to charge them with the bigger crime. How can we do this? They can offer them a deal. The offer. If no one confesses to robbery, the police can only charge the prisoners for trespassing. The punishment would be 1 year in jail, each. If one confesses and the other doesn't, the police will be lenient on the one who told and severely punish the quiet one. The punishment would be 10 years in jail for the quiet one and 0 years for the other. If both confess, the police punish both of them equally. The punishment would be 5 years in jail each. We can put all this information into this matrix. The rows always reflect player one's moves and the columns always reflect player two's moves. Meanwhile, the first number in each cell corresponds with player one's payoffs while the second is for player two. An important game theory convention that will help make solving the problem better and easier is that we can make player one always a man and player two always woman, so that we can use pronouns like he, she, his, and hers without any confusion. Moving on, we can see that both players are better off defecting regardless of what the other player does. Let's start by looking at player one's options. Assume he knew player two would cooperate, while player one's best response in this case is to defect. Cooperating will get him 1 year in jail, while defecting allows him to walk away. Now let's assume player two will defect, and it's the same thing. Player one is better off defecting, as well as if he cooperates, then he will spend 10 years in jail. If he defects, he'll only spend 5. Since 5 years is better than 10 years, he should defect in this case. Consequently, it is very obvious that player 1 will defect in this case, no matter what player 2 does. Player 1 is strictly better off by defecting. According to the game theory, the defect strategy strictly dominates the cooperate strategy. Let's look at player two's options. Imagine player one cooperated as we saw with player one last time. Player two's best response is to defect. He has no time and jail is better for her than 1 year is. If player one defected, player two's best response is to defect as well, since 5 years in jail is better than 10 years. So the defect strategy completely dominates cooperate for her as well. Meanwhile, player 2 will defect in this game. Thus we have an equilibrium defect. Each of the prisoners will be better off with the outcome if they both cooperated, as they would only spend a year in jail. Despite but because there is a temptation to screw over the other prisoner by defecting them. Defect equilibrium is the only stable outcome.